So as you can see, so when it is positive we are considering it as RHL, that means right hand side of the number. For example, the number is located here, then the limit would be located just just very small. For a very small amount it would be located there. Okay, for example 1.00001 or 0.00001, like this. Now we can say for a number its limit exists if LHL is equals to RHL. Okay, this is a very important property. If and only if this occurs, we can say that limit of the number at that particular interval exists. The function may be continuous and the limits of the function may exist throughout its, what, let's just say, throughout its path, for better simplification. But at this interval we are considering that limit exists. Okay, now there are some rules of limits, known as algebra of limits, which we'd learn. Now, just to give you an introduction, I use this. I will explain you the basics and main fundamentals of limits. That means exercise 1 of NCRT book class 11 later. But now, let me explain you something else. Let me explain you algebra of limits. Okay. According to algebra of limits, it states, for example, limits exist between fx is a function, and gx, where lim x tends to some number n, plus gx, where lim of x tends to another number n. Both of them should have the same limit. Both of them should tend to n. Remember that point. Then f plus gx is equals to this. Okay, so this is the first, yes, so this is the first rule for algebra of limits. Next, let us see what next we have. Fx dot gx, again we are not writing limits as it would